Chapter 2 of Spacehounds of IPC by E. Doc Smith. This LibriVox recording is in the public domain. Spacehounds of IPC. Chapter 2 But Does Not Arrive. "All out. We climb the rest of the way on foot," Stevens told his companion as the elevator stopped at the uppermost passenger floor. They walked across the small circular hall, and the guard on duty came to attention and saluted as they approached him. "I have orders to pass you and Miss Newton, sir. Do you know all the combinations?" "I know this good old tub better than the men that built her. I helped calculate her," Stevens replied, as he stepped up to an apparently blank wall of steel and deftly manipulated an almost invisible dial set flush with its surface. "This is to keep the passengers where they belong," he explained, as a section of the wall swung backward in a short arc and slid smoothly aside. "We will now proceed to see what makes it tick." Ladder after ladder of steel they climbed, and bulkhead after bulkhead opened at Stevens's knowing touch. At each floor the mathematician explained to the girl the operation of the machinery there automatically at work, devices for heating and cooling, devices for circulating, maintaining, and purifying the air and the water. In short, all the complex mechanism necessary for the comfort and convenience of the human cargo of the liner. Soon they entered the conical top compartment, a room scarcely 15 feet in diameter, tapering sharply upward to a hollow point some 20 feet above them. The true shape of the room, however, was not immediately apparent, because of the enormous latticed beams and girders which braced the walls in every direction. The air glowed with the violet light of the 12 great ultra-light projectors, like searchlights with 3-foot lenses, which lined the wall. The floor beneath their feet was not a level steel platform, but seemed to be composed of many lenticular sections of dull blue alloy. "We are standing upon the upper lookout lenses, aren't we?" asked the girl. "Is that perfectly all right?" "Sure. They're so hard that nothing can scratch them, and of course Roser's rays go right through our bodies, or any ordinary substance, like a bullet through a hole in Swiss cheese. Even those lenses wouldn't deflect them if they weren't solid fields of force." As he spoke, one of the ultralights flashed around in a short, quick arc, and the girl saw that, instead of the fierce glare she had expected, it emitted only a soft violet light. Nevertheless, she dodged involuntarily, and Stevens touched her arm reassuringly. "All X, Miss Newton. They're as harmless as mice. They hardly ever have to swing past the vertical, and even if one shines right through you, you can look at it right in the eye as long as you want to. It can't hurt you a bit." "No ultraviolet at all?" "None whatever. Just a color, one of the many remaining crudities of our ultralight vision. A lot of good men are studying this thing of direct vision, though, and it won't be long before we have a system that will really work." "I think it's all perfectly wonderful," she breathed. "Just think of traveling in comfort through empty space, and of actually seeing through seamless steel walls without even a sign of a window. How can such things be possible?" "I'll have to go pretty well back," he warned, "and any adequate explanation is bound to be fairly deep wading in spots. How technical can you stand it?" "I can go down with you middling deep. I took a lot of general science, and physics through advanced mechanics. Of course, I didn't get into any such highly specialized stuff as subelectronics or Roser's rays, but if you start drowning me, I'll yell." "That's fine. You can get the idea all X with that to go on. Let's sit down here on this girder. Roser didn't do it all by any means, even though he got credit for it. He merely helped the Martians do it. The whole thing started, of course, when Goddard shot his first rocket to the moon, and was intensified when Roser so perfected his short waves that signals were exchanged with Mars, signals that neither side could make any sense out of. Goddard's pupils and followers made bigger and better rockets, and finally got one that could land safely upon Mars. Roser, who was a mighty keen bird, was one of the first voyagers, and he didn't come back. He stayed there, living in a spacesuit for 3 or 4 years, and got a brand new education. Martian science always was hot, you know, but they were impractical. They were desperately hard up for water and air, and while they had a lot of wonderful ideas and theories, they couldn't overcome the practical technical difficulties in the way of making their ideas work. Now, putting other people's ideas to work was Roser's long suit. Don't think that I'm belittling Roser at all, either, for he was a brave and far-sighted man, was no mean scientist, and was certainly one of the best organizers and synchronizers the world has ever known. And since Martian and Tellurian science complemented each other, so that one filled in the gaps of the other, it wasn't long until fleets of space freighters were bringing in air and water from Venus, which had more of both than she needed or wanted. Having done all he could for the Martians, and having learned most of the stuff he wanted to know, Roser came back to Tellus and organized Interplanetary, with scientists and engineers on all 3 planets, and set to work to improve the whole system, for the vessels they used then were dangerous, regular man-killers in fact. At about this time, Roser and the Interplanetary Corporation had a big part in the unification of the world into one nation, so that wars could no longer interfere with progress. With this introduction, I can get down to fundamentals. Molecules are particles of the first order, and vibrations of the first order include sound, light, heat, electricity, radio, and so on. Second order, atoms, extremely short vibrations such as hard X-rays. Third order, electrons and protons, with their accompanying Millikan or cosmic rays. Fourth order, subelectrons and subprotons. These, in the material aspect, are supposed to be the particles of the fourth order, and in the energy aspect they are known as Roser's rays. That is, these fourth-order rays and particles seem to partake of the nature of both energy and matter. Following me? Right behind you, she assured him. She had been listening intently, her wide-spaced brown eyes fastened upon his face. Since these Roser's rays, or particles or rays of the fourth order, seem to be both matter and energy, and since the rays can be converted into what is supposed to be the particles, they have been thought to be the things from which both electrons and protons were built. Therefore, everybody except Norman Brandon has supposed them the ultimate units of creation, so that it would be useless to try to go any further. "Why, we were taught that they are the ultimate units," she protested. "I know you were, but we really don't know anything, except what we have learned empirically, even about our driving forces. What is called the fourth-order particle is absolutely unknown, since nobody has been able to detect it, say nothing of determining its velocity or other properties. It has been assumed to have the velocity of light, only because that hypothesis does not conflict with observational data. I'm going to give you the general accepted idea, since we have nothing definite to offer in its place, but I warn you that the idea is very probably wrong. There's a lot of deep stuff down there that hasn't been dug up yet. In fact, Brandon thinks that the product of conversion isn't what we think it is at all, that the actual fundamental unit and the primary mechanism of the transformation lie somewhere below the fourth order, and possibly even below the level of the ether. But we haven't been able to find a point of attack yet that will let us get in anywhere. However, I'm getting way ahead of our subject. To get back to it, energy can be converted into something that acts like matter through Roser's rays, and that is the empirical fact underlying the drive of our spaceships, as well as that of almost all other vehicles on all 3 planets. Power is generated by the great waterfalls of Tellus and Venus. Water's mighty scarce on Mars, of course, so most of our plants there use fuel, and is transmitted on light beams by means of powerful fields of force to the receptors, wherever they may be. The individual transmitting fields and receptors are really simply matched frequency units, each matching the electrical characteristics of some particular and unique beam of force. This beam is composed of Roser's rays, in their energy aspect. It took a long